All right, this is Form A from yesterday's electrostatics quiz. So I'm just going to go through this one question at a time. Overall, the average on this thing was a 80%, so you guys did pretty well on it. But as we go through it, I'll let you know how you did on each individual question. Question 1, 88% got correct, so almost everybody got this one right. It says object A has a charge of 100,000 coulombs and object B has a charge of negative 1.60 times 10 to the negative 19th coulombs. Which statement best describes the electrostatic forces acting on these objects? This question does have a typo in it, if you notice, because B and C say the exact same thing. Okay, they're not the answer though, so it doesn't really matter. But if you had picked one or the other and we had a typo like this on an actual assessment and it was the right answer, we would have counted them both. But in this case, they're both wrong. So anyway, it says answer A says object A exerts a greater force on object B since it has a greater charge. Answer choice B says object B exerts a greater force on object A since it has a lesser charge, which is also what C says. And then D says they exert identical forces on each other since forces come in pairs, and that is your answer. It even says since forces come in pairs on it. But yeah, again, we went over this multiple times, and I've told you in pretty much every unit where we've talked about this that for every action there's an equal and opposite reaction. It goes back to Newton's third law. But we had a warm-up question about this too. Okay, but you want to make sure to tell me that those forces are equal and opposite to each other. They make up a force pair. Even though they have drastically different amounts of charge, it doesn't matter. They're going to attract one another because they have opposite charges, and that attraction will be equal and opposite for both. So the answer to number 1 is D, and as I said, 88% of you guys got that right, but that does mean that there were a fair number of you that missed that question. All right, number 2, on the other hand, was one of the most missed questions, actually the most missed question on the quiz. Number 2 says a positively charged glass rod, and it gives you the charge positive 2 nanocoulombs, touches a piece of metal with a charge of negative 4 nanocoulombs. What is the final charge state of the metal? Again, this is an example of charging by conduction because it says that they are touching one another. Okay, and when they touch, the charges are going to redistribute themselves so that you have equilibrium, electrostatic equilibrium. Right now, this object has an excess of electrons, and those electrons repel each other. They don't want to be near each other. On the other hand, this object has a lack of electrons. It doesn't have enough of them, so it has more protons than electrons. And so it's going to attract electrons because opposites attract. So those charges are going to flow from here to here, but not all of them. They're going to flow until they reach a balance. Okay, and so that's what our job is, to figure out what that is. I told you guys, and when we did this in our notes, that in order to determine the final charge state, you would add them together and divide by 2. You're literally just finding the average. Okay, so that would be 2 plus negative 4, which is negative 2. That's the total charge of the system, and then divided by 2, because each of them ends up with the same charge. That means one of them is going to be negative 1, the other one's also going to be negative 1, but each of them is going to have a charge of negative 1 nanocoulomb, which is answer choice B for number 2. Those of you that got it wrong picked A. You forgot to divide it by 2. Okay, but you want to know the charge of each of them. They're each going to be negative 1. The total charge is negative 2, but each of them has a charge of negative 1. All right. Any questions about number 2? Number 3, we just went from the most missed question to one of the least missed questions, because number 3, 96% of you guys got right, campus-wide. Number 3 says calculate the magnitude of the force between two charges of 6 times 10 to the negative 8th and 2 times 10 to the negative 7th if they are 0.5 meters apart. This is just straightforward calculation using Coulomb's law. Your equation for Coulomb's law was on my board during your quiz, but it's also on this formula chart that I'm showing you right here. But your electrostatic force is equal to your constant K times Q1 and Q2, which are your charges, and then divided by the distance between them squared, which is labeled as R squared on here. And so that's exactly what you do. Oh, by the way, the constant, that K value right here for this constant is right here, 8.99 times 10 to the 9th. And again, it's on the board as well. So whenever you go in and you solve this, that's exactly what you're going to do. You are going to do 8.99 times 10 to the 9th multiplied by the two charges, 6 times 10 to the negative 8th, and the other charge is 2 times 10 to the negative 7th. And then all of that gets divided by your distance between them squared, which is 0.5 squared. And so that's the answer that you get if you calculate it correctly. I do know that some people, when I'm looking at the way you're calculating it, are forgetting to square that distance in the bottom, or you're typing in some of these things incorrectly. But the answer that you should get when you do it right is answer choice A, which, as I said, 96% of people campus-wide got that one right. Questions about number 3? All right. Number 4. Number 4 says, as Mr. Boyd runs a plastic comb through his hair, the comb acquires a negative electric charge. This charge results from the transfer of, and you have some options here that A and B involve protons moving between the comb and the hair, and C and D involve electrons moving between the comb and the hair. So first things first, you should be able to eliminate A and B. Please don't tell me that protons move. We are not altering the nucleus of an atom. There's nothing nuclear reaction going on here. The only thing that's going to be transferring are those electrons, and your electrons are going to transfer because it tells you right here that the comb acquires a negative charge. That tells me where they go. The electrons are negatively charged, and so they are going to the comb because the comb acquires a negative charge. That means they had to have come from the hair, and so electrons from his hair to the comb is your answer, which for number 4 is answer choice D. 93% of you got that right, so almost everybody, but again, there were some of you that missed it. Are there questions about number 4? All right. Number 5. Let's go ahead and scoot this so we can see it. It says, use the information in the image below to answer the following 2 questions. If you had Form A, the next question is on the next page, the one that goes with this, so hopefully you figured that out. But it says, examine the electric field lines surrounding the 2 charges Q below. Various points are labeled in the field. And then number 5 says, at which lettered point is the electric field strongest? And then it says, note, read the answer choices below carefully. And it says that because A is A, B is B, C is C, but D is E. So hopefully you read those carefully and didn't, like if you wanted to pick E, hopefully you also, that you bubbled D and not E. But it's not the answer, so it probably shouldn't have thrown you off, because where it's the strongest is going to be where your field lines are closest together, which is not point E anyway. Where the field lines are closest together is, based on the choices here, is going to be answer choice C, which is actually why we didn't put D in it, because that would be pretty similar to C. And so that at point C, which is right here, is where your field lines are closest together, and so your answer to number 5 should be C. Questions about number 5? All right, then let's take a look at number 6, which also goes with this same diagram. Number 6 says, based on the electric field diagram shown, it's on the previous page, but it is shown, which shows the correct free body diagram illustrating the electric forces on the 2 charges, Q1 and Q2. The charges are both positive, so you need to remember opposites attract and like charges repel. This is an example of like charges repel because they have the same charge. So we do want to make sure that the free body diagram we choose shows repulsion, which means that it can't be A, that shows attraction, and it can't be D because it shows attraction. So we're left with B or C, both of which show two charges repelling each other. Again, it doesn't matter if the charges have different masses. It doesn't matter if the charges have different magnitudes of charge. This will always be a force pair. Okay, and so the answer is B. I don't even have to go back and look at it to see which one was stronger. It doesn't matter. Okay, even if one of them was stronger, we would still say that those forces are equal and opposite. The answer to number 6 should be answer choice B, and 92% of you guys got that one right. Are there any questions about number 6? All right. Number 7. Number 7 says each diagram below shows two pith balls, the foam balls coated with aluminum, hanging from strings. A pith ball can be given a positive or negative charge. Which of the following diagrams shows the correct interaction based on the charges shown that would occur between two pith balls? So if you look at these diagrams, some of them are labeled positive, some of them are labeled negative. So like if you look at answer choice A, if this was positive and this was negative, would they do this? And the answer is no, because opposites should attract. So this is not your answer. That's all you're doing. You're looking at each one individually. Would this happen? Okay, so A would not happen. B shows a positive, and it shows them attracting each other. That also would not happen. Like charges should repel. If these two were flip-flopped, and this was plus plus and this was plus minus, then they'd both be right. Okay, but right now A and B are both wrong. C shows repulsion between two positive charges. That is what would happen. Two positive like charges would repel. So C is the answer, but let's take a look at D. D shows two negatives attracting. Again, like charges should repel. Okay, so whether they're positive or negative, repulsion looks like this. The answer to number 7 should be answer choice C. Questions about number 7? You guys, 98% campus-wide got that right. That was the most correct answer on the whole thing. All right, number 8. Hmm. 90% of people got number 8 right. It says, the diagram above, that should say below. The diagram below shows electric field lines in an isolated region of space containing two small charged spheres, Y and Z. Which of the following statements is true? So answer choice A says the charge on Z is positive and the charge on Y is negative. So let's start with that statement. When I look at the free body diagram, any free body diagram, I can tell the charge by looking at the direction of the arrowheads. Positive charges will have arrowheads that point away from them, which means that this one has to be the positive charge. And this one has arrowheads pointing toward it. It has to be your negative charge. So those are your charges, which is not what this says. This says Z is positive and Y is negative. So that's exactly backwards, so it's not A. B says the charge on Y is positive and the charge on Z is negative. That's exactly what I just labeled. So right now that looks like my answer, but let's double check and make sure there's not like all of these. There's not, but the next one says they're both positive or they're both negative. They're not. Like charges, you would see a different pattern to your field lines. This is what attraction looks like. Repulsion looks like that previous diagram that we looked at over here. That one, that's repulsion. This is attraction. Okay, so the answer to number 8 should be answer choice B. Questions about number 8? As I said, most people got that right. This next one, though, fewer people got right. So let's take a look at number 9. It wasn't the most missed question or anything, but it was one that some people struggled with. Only 70% of people got this one right. It says, two charges exert a force of 4 newtons on each other when separated by 1 meter. What would the force be when the magnitude of both charges are doubled? So again, my equation for Coulomb's law is going to outline the relationship between these variables. Okay, and the equation looks like this. Okay, or it has an R on the formula chart, but it's the same idea. So it's saying, hey, what if I double both of these? What if they're both times 2? Okay, well, charge is directly proportional to force, but if I double them both, then this is going to double it, and that's going to double it again. Okay, which means it would be 4 times as much force because you're doubling both of the charges, not just one of them. So the original amount of force was 4 newtons. If I have 4 times the force, that's 16 newtons. The answer to number 9 should be A. Okay, so number 9 should be A. Are there any questions about number 9? I'm assuming some of you did not read the fact that both of them were doubled because the most common wrong answer was C. All right, let's look at number 10, which was about as missed as number 9. 68% of people got number 10 right, a little bit less than number 9. It says, which of the following pairs of charged particles experiences the greatest magnitude of force between them? Again, when I look at Coulomb's law, I can see that the factors that affect the amount of force between 2 charged particles are charge and distance. Okay, charge, the magnitude of the charge has a directly proportional relationship, whereas the distance has an inverse squared relationship. But if I look at these, like A and D, for example, they have the same distance between them. So let's compare those first, because we can eliminate some and not have to do math for everything. Okay, if I compare A and D, this one's -3 and +3. This one's -3 and -5. This right here is more charge than I had in the previous one. So that means that the force of attraction in D is greater than A. And if I'm looking for the greatest, that means it can't be A. Now, it's not necessarily D either. We need to check the other ones. I'm now going to compare B and C because they have the same distance. And we're just going to pick which one has more total charge, because I know that charge is going to mean, if I have more charge, it's going to mean that I have more force of attraction. This is positive, or repulsion, because it just says magnitude of force. This one's +5 and -5. This one's +4 and +5. 4 is less than 5. That one's smaller than that one, and so it can't be B, which means my answer is either C or D. Okay, now, again, I should have a stronger amount of force when I'm closer together. However, these charges are smaller than these, so we should just double check it with the math. Okay, now that we've eliminated some, you don't have to do math 4 times. Now, if you want to do the math 4 times, do the math 4 times. That's fine too. Okay, but let's go ahead and calculate. Again, we're going to be using Coulomb's law, which is, again, this equation right here. Okay, so let's try that with both C and D. Now, I'm not going to worry about the fact that that says that it's a microcoulomb because they both say microcoulomb, so I'm just going to use the number from the circle. I'm not going to worry about that prefix because I'm just comparing them. I don't need an actual number answer. All right, so if I want to do C, again, my constant, you can still see it from the previous problem, 8.99 times 10 to the 9th multiplied by 5 and -5. Again, I'm looking for magnitude. I don't care that it's a negative. I'm just going to multiply by 5. Okay, and then I'm going to divide by the distance between them squared. 3 squared is 9. So that top one gives me this value, and we're going to compare it to what we get down here. So we're going to do the same thing again, 8.99 times 10 to the 9th. Oops, what was that? And then multiply by these charges, 3 and 5. And then divide by the distance between them squared. This is 2 squared, which is 4. All right, so those are the two values that we're comparing. They have the same exponent at the end, so we're really just comparing the coefficients. Okay, this one is 2.5, this one's 3.4. That's what you're comparing. And the question wants to know the greatest force. 3.4 is obviously greater than 2.5, so my answer is going to be answer choice D. This is a greater force of attraction, or yes, repulsion. Magnitude of force is greater there than it is for the other one. So the answer to number 10 should be D. Are there any questions about number 10? Again, this was something that was missed by a lot of people. Again, if all you did was the math for each one, you could have just compared the numbers that way. If you'd rather do that than process of elimination like I did, that's fine too. Okay, let's take a look at number 11 if nobody has any questions on 10. Number 11 says, number 11, by the way, was the second most missed question, so listen up because the odds are that you missed it, and I say that because, well, it's about 50-50. This one was 50% of people got it right, so about half the class probably missed this question. This is campus-wide data, so maybe our class was better, maybe a little worse. I don't know, I haven't checked. But it says 2 charged coins are 4 meters apart from each other. The $1 coin has a charge of positive 3.337 times 10 to the negative 4th coulombs and is attracted to the 1 pound coin with a force of 62.6 newtons. Determine the charge of the 1 pound coin. Before I do any math, I'm going to focus on this right here. It's attracted to it. Its charge is positive. So right off the bat, I know that the charge of the other coin has to be negative. Opposites attract. I can eliminate half of my answer choices. Please do that. Okay, that means that if they're attracted, that I can't have a positive charge on the other coin. It has to be negative. Okay, so that means it's either A or C. Now we just have to do the math to figure out what the actual charge is. Okay, so let's go ahead and calculate it. Again, we're using Coulomb's law. This time they gave us the force. So I'm using this same equation right here, but they gave us the force. So they said the force is 62.6, and we're going to set that equal to the constant, which is 8.99 times 10 to the 9th, and then multiplied by my charges, 3.33, this is really hard to fit on here, 7 times 10 to the 4th, and then my other charge is what I'm solving for. I can't even fit it. I need more space to write this out. Q2, whatever. And then all of that over, I know it's not neat, but all of that is over the distance between them squared. The distance is 4. Okay, so it'll look cleaner in my calculator, I guess. But if I'm going to solve for this, okay, I need to get that by itself. So we can start by multiplying both sides by 4 squared. So let's do 62.6 times 4 squared. Or if you want to do times 16, since it's the same thing, you get this, 1001.6, and that's going to be equal to, I'm going to rewrite it, 1001.6 is going to be equal to 8.99 times 10 to the 9th, that's my constant, times 3.337 times 10 to the 4th times Q2. Okay, so that is now my equation. So now I just need to divide both sides by these values right here to get this by itself. Okay, so if I take my answer and I divide it by 8.99 times 10 to the 9th, and then I divide it again by 3.337 times 10 to the 4th, then that should be my answer for Q2. 3.3387 blah times 10 to the negative 12. And again, I've already determined that it's negative. Now the reason some of you missed this is because your calculator doesn't tell you that it's negative. You have to go in and say, hey, it's attracted. You have to check the sign at the end. Please check the sign at the end. Okay, but I got 3.33, and it kept going from there, times 10. I have a different exponent here. Did I type something in wrong? Oh, I didn't push a negative 4. That's why. Thank you. All right. These nails are making it hard to type anyway, but I'll type it one more time just so we can get the actual right number. She is absolutely right. I did not type negative 4. 3.337 e negative 4. Now we have the right exponent. Okay, and it's A, because again, I've already determined that it was attracted. I needed a negative sign. Double check your sign at the end, because the calculator doesn't give me that negative sign. All right, so number 11 should be A. I'm assuming if you missed it, you probably put B. Let's look. Yep, most common wrong answer was B. So that means you did the math right. You just forgot to check your sign at the end. All right. Number 12. Number 12 says true or false. An object that becomes grounded gains neutrons during the grounding process. That is false. We have not at any point ever talked about neutrons really at all. The only charge that is going to be moving is the electron. Again, if you alter protons or if you alter neutrons, you're altering the nucleus of the atom. That is not what we're talking about. Okay, we cannot do that. Not without a nuclear reaction. So we're just talking about electrons here that are moving, and so 12 is false. 90% of you guys got that right. Number 13, also 90% got it right. It says, which of the following explains how a negatively charged balloon sticks to a neutral wall? It says, in answer choice A, the balloon pushes the negative charges away from the wall's surface, resulting in positive charges on the wall's surface that are attracted to the negative balloon. That is actually what happened. If you remember the simulation that we did, you've done this in a PhET. You've seen it in animation in my notes. But it causes polarization of the wall. A is the answer, okay, that you should be picking. B says the negative balloon transfers protons to the wall. Guys, if the question or answer choice says anything at any point about transferring protons, don't pick it. It's not right. C says the negative balloon gains electrons from the wall. No, that is not what, first of all, it's not a conductor, but secondly, that is not what would happen even if it could. If you had a negative object touching a neutral wall, assuming that they were both conductors and charges could flow, that is not the way they would flow. They would flow from the negative balloon into the wall, not the other way around. And then D says both end up neutral because touching the two together causes charges to balance and stick together. If you had two conductors and you touched them and the charges could flow freely, they might do that. But again, a balloon and a wall are not going to be made out of conductors. So the answer that you should have picked for number 13 is answer choice A. Are there any questions about number 13? No? All right. Let's take a look then at number 14. We are almost done. Number 14 says, what happens when a positively charged rod touches a neutral metal-coated ball? Again, I told you a minute ago, if it ever says protons move, don't pick it. So you should automatically be eliminating C and D. I don't even have to read the whole statement. It says protons move, it's not the answer. So the electrons are moving. The question is which way? If this rod is positively charged, then your electrons want to go into the rod. Okay? Even though the ball was neutral, doesn't matter. This is positive. Opposites attract. It's going to steal electrons from this ball. And so your electron should move from the ball into the rod, which is answer choice A for number 14. Are there any questions about number 14? This was one that some of you struggled with. Only 78% of you got it right. So again, make sure that you're making mental note or maybe even making actual notes on paper. Even better. All right, this is the last question on the quiz, and some of you, a couple people anyway, forgot to turn the page. So some of you only answered 14 questions. Number 15. Guys, always check the back page, just in case. Some of them had more than one question on the back. This one only has one. Number 15 says, an electrostatic force exists between two charged particles. Each particle has a charge of positive 3.20 times 10 to the negative 19th coulombs, and they're separated by a distance of 0.03 meters. As the distance between the 2 point charges is decreased, the electrostatic force will do what? Okay, so first of all, you're starting out with them far apart, and then you're going to move them so that they're closer together. So the question is, how does moving them closer together affect them? The other thing we need to know is that these both have the same charge. It says each particle has this charge. So both of them are positively charged. And so the question is, when I move two positive charges closer together, what happens? Well, first things first, they repel. Like charges repel. So we're not dealing with attraction. You can eliminate A and B. When you move them closer together and you have a smaller distance of separation, you will have a larger force of attraction. Again, you can see the relationship in Coulomb's law as well, because if this number gets smaller, you're dividing by a smaller number, you're going to get a bigger answer. There's going to be a larger force. So you can look at the relationship here, or you can just look at it or just remember it, because it hopefully makes sense to you that if they're closer, they're going to attract or repel more. But the repulsion between the two charges would increase, which is what answer choice D says for number 15. They would be even more repelled by each other. There'd be a stronger force between them. Are there any questions about number 15? All right, guys, that is it for today's quiz then. What I would recommend that you do for the rest of the class period is to look over your unit summary or your problem sets or any of those things that might help you to better prepare for your test, because you do have a test on Thursday. As I said, this recording will be uploaded so that you can take a look at later on at this quiz again if you are trying to look for something else to review. Your test, the multiple choice section, is going to look pretty similar. But your test is also going to contain some free response. And so you may want to look back over that stuff or go back through that unit summary or those problem sets, or even go back and look at the simulations that you did, because you're going to have questions related to the stuff that we've been doing throughout the unit. And there's going to be a couple different ones. There's going to be some math, but there's also going to be, hey, explain what's happening here, or which way things are moving, or what's the charge on this, or whatever. So you're going to have to be able to explain it as well. So it may help to go back and look at those simulations again, because it is a very visual representation. All right, guys, I'm going to stop talking, let you guys get to it. If you have questions, let me know. But what I would recommend you do for the rest of the period is, if you have any missing assignments, take care of those first. But if not, then please take a look at that unit summary.